Bismillahirrahmanirrahim. Assalamu alaikum. Today we will perform experiment number 9 to display the working of voltage to current and current to voltage converter for electrical measurement systems using hardware. VI converters, that are voltage to current converters. Why they are used? For analog representation of certain physical quantities like weight, pressure, motion, etc., that are measured from the sensors, they require DC current in order to perform in my instrumentation circuits, because DC current signals remain constant throughout the circuit in series from the source to load. The current sensing instruments also have the advantage of less noise. So sometimes it is essential to create the current which is corresponding or proportional to a definite voltage. For this purpose, we use voltage to current converters. Next are the IV converters, that are current to voltage converters, and why they are used. Many times the sensor or the circuit component like photodiode gives the output in the form of the current, and it needs to be converted into the voltage to process it or use with the data acquisition system. That is why we need current to voltage converters. The main objective of this experiment is to sketch the output characteristics of VI conversion system for electrical measurement systems using MCM7A operational amplifier module. The second one is to sketch the output characteristics of I to V conversion system for electrical measurement systems using MCM7A operational amplifier modules. Previously, we have performed our experiments based upon the discrete components, but this experiment is totally based upon hardware. The module MCM7A contains all the integrated circuits containing the resistors, capacitors, and other components. We will be using variable power supply in order to change the voltage value, MCM7A operational amplifier module, and a digital multimeter. Next, we have a diagram of voltage to current converter. This is integrated on your MCM7A module. We do not need to construct it on the breadboard or NI-Elvis board. This is the circuit diagram of I to V converter. This is also integrated on the module. Next, we will have our demonstration session, which is performed in the laboratory. Let's have a look. Let us start our experiment number 9, to display the working of voltage to current and current to voltage converters for the electrical measurement systems using hardware. We will use MCM7A converter. It has two sections, voltage to current and current to voltage converter. At left side we have VI converter, and at the right side of this module we have I to V converter. Here are some switches attached with which adjust the value of the voltage and current changes accordingly. Here are shown some jumper wires for the power supply cables. We will give input as voltage, and at output we will get the current. This is the circuit diagram which is integrated on the module. We need to find the relevant current across the voltage. This is the circuit diagram containing two amplifiers and one transistor and one Zener diode and a variable resistor. When we supply the voltage to the circuit, the variable resistance acts as a reference and voltage is amplified from the first amplifier, which is at the left corner of the circuit. And at the amplifier number 2 there is a Zener diode connected in reversed bias position, which will act as a regulator along with the second operational amplifier and give the signal to the base of the transistor at the end of the circuit. Now we will see this configuration on our MCM7A module. Most of the sensors operate at 4 to 20 milliampere current and 0 to 8 volt. We often find current driven systems, they need to be converted into current or voltage. This is our variable power supply and we set 8 volts. We can change the voltage value by moving its knob. Now we measure the input value. It needs to be set at 8 volts. You can see it is near to 8 volts. Now we will measure the output voltage across this input supplied at 8 volts. We will connect our ammeter at output in order to find the current. Now we will adjust our knobs and we can see the readings at our ammeter. It needs to be adjusted at micro or milliampere mode. According to the circuit, it should give the 20 milliampere current across the 8 volts. So we will see after adjusting some parameters. Here is 20.7 milliamperes, which is very close to 20 milliamperes. It shows our design is right. Next we have some questions in the manual which we have to fill after performing this whole experiment. We will be able to answer the asked question in the manual. At this position we can connect our load. So we will see this in upcoming step. 150 ohm is the maximum value which is maximum that it can bear. Now we will switch on S3, which is available at our module, and we will measure the current. Let's see what happens when we switch on S3. Now we will measure the current value, whether it changes or not. Yes, we can see it is 1.9 microamperes. It means the current value has decreased. Now switch off S3 and switch on S11, which is also available on the module. Now it is 41.4 microamperes. It is a huge change in the amount of the current. So our experiment is working properly. Now for part 2, we will use this obtained output current as the input of our second circuit, that is current to voltage converter. In a similar fashion, we will perform the part 2. Now we can see this particular circuit is designed to give 8 volts across 20 milliamperes. So practically it should follow the rule. Now we will measure the output of IV converter at ammeter to have a look whether this circuit or the principle is right or not. You can see we get a 9.69 volt as an output. So this integrated circuit is performing in a better accuracy. Here is the reference voltage set at 12 volt and here is a variable resistance. If we adjust the variable resistor, we can also change the value and we can get 8 volt. Now switch on S4 and measure the voltage. We will see the effect on the output. It has decreased. Now switch off S4 and switch on S13. We will do this like we did before. Now it is 11.04. It means after changing the resistance or load, we obtain a different value of the voltage at output. Now switch off S4 and switch on S13 and again. Now switch off S13 and observe the voltage value, that is same. Thank you. If you have any questions, please feel free to ask in discussion session. Thank you.